world because, well, you know, in the big scheme of things, the quiz is worth relatively little compared to some other things in the course, like tests, right? But let's talk about the solution here. So, any questions before I get into it? I'll leave that one on. Let me make it bigger. So I, you know, I don't know, 120 people took this quiz, something like that, and nobody noticed that my first problem had an error, because like if you actually go through the steps of graphing this thing, it ends up, it's not shifted down. Like the one that's given, I've got it going down here, and like this graph that was given is none of these. Now, I understand the way you solved this problem was you looked at it, you went absolute values, absolute value, so it's a V, right? Since it's a V, it's got to be that one, and that's like that's the level of the thinking, and that's exactly what I wanted you to do. So wonderful. That is actually the kind of understanding I want you guys to have. That's the surface level graphing, right? That is an intended goal of this class. That you have achieved that is actually very important to me, because I do want you to have a quick and easy way of looking at this and going, well, that's got a vertical asymptote, so it's got to have something division by 0. It's got to be this one, you know? And I look at this one, I'm like, well, I guess if you use your imagination, you can see that this is half of a parabola turned sideways. So it's got to be a square root, you know? This one, it looks like a cubic, but it's turned sideways. It's got to be a cube root, you know? And so that level of thinking is enough for this problem, right? However, how would you have fared on this problem? Imagine a universe where I gave you 4 of the same kind of graph, where I actually had 4 different transformations indicated. Could you do that problem? Maybe. That one would actually require a little bit more thinking, right? So, you know, for example, I could have 4 different parabolas, all with different vertices, you know, and then I could have 4 equations of a parabola. You have to figure out which one's which. That would be an interesting problem, right? Or I could have 4 different, you know, absolute value ones and actually have the 4 different graphs correct. So, but anyway, I don't think this error actually hurt anybody. If it did hurt you, and it like affected your grade or something, just let me know. I'll adjust. But I don't think that's actually the case for anybody. Okay, let's go on to more interesting things. Problem 2. Problem 2. And by the way, I don't have this solution posted in Canvas yet. I will post it in the early evening tonight, all right? So that's my plan. So this one here, you're supposed to find the coordinates and of the vertex and the x-intercepts, right? So to find the vertex, I complete the square, all right? And when I do that, I get x minus 4 squared minus 5. Once I have this, I can see from that, just looking at it, that the vertex is at 4 comma minus 5. A lot of you have a minus 4 instead of a 4 here for various reasons. Yeah. Mostly just like misinterpreting the form, I think. Some of you use the formula that we derived in class for the vertex, right? That's fine, but you got to make sure you use it carefully. I have a lot of people using it carelessly and getting the wrong vertex, unfortunately. So let's see here. And then the x-intercepts, to see x-intercepts, you want to factor it. So if I factor it, I get this. And then from that, I can see I've got 4 plus or minus the square root of 5 as places where this is 0, which means my x-intercepts are respectively this and that, right? And I didn't expect you to find the decimal form. I'm just writing this down because there's a subset of you who will like write that. And I didn't, like if you wrote that and you didn't write the other, I wanted to give you like full credit for that just because to see it, you know. So that's mostly for me, just for my grading, so I don't miss it if you guys happen to write that instead of the, you know, exact form above. Any questions? So I think everybody should get this problem. If I was to ask this exact question again on the test, right? With different numbers here, obviously, right? You should be able to get it, right? I think everybody can get this problem. It's not that complicated, really, right? So. The same is true for problem 3. Everybody can get this problem on the test. There is no reason you cannot get this problem if I ask it again, right? We just have to pay attention to the details here. So, well, first of all, we have to be able to factor, right? So if you can factor this correctly, that's the first hurdle, right? But I think most of you could factor that. I think that wasn't actually an issue that was not an issue for most people. Most people did factor the numerator and the denominator correctly here, so that was good. Once you do that, places where either the numerator or the denominator are 0 are your critical numbers. So here, -2 makes the numerator 0, 2 makes the numerator 0, -1 makes the denominator 0, and 2 also makes the denominator 0. So the number 2 is really different in its nature than the other two numbers, right? Like this 2, it's x minus 2 above and below, right? So that makes 2 a place where there's going to be a hole in the graph, all right? In contrast, -2 is an x-intercept, is where an x-intercept is at, because it's making the numerator 0 and only the numerator 0. So that gives you an x-intercept, right? X equals to -1 makes the denominator 0, but it doesn't make the numerator 0, right? So that's just a plain old vertical asymptote. Now, a lot of you had like a list of numbers here. Like I think there's a lot, probably 20% of the class has just put -2, -1, 2 here, or something like that. So you give me a list of numbers there, I don't know what to do with it, because it's definitely only one thing. You know, so if you give me more than one thing, you're not understanding something about it. And the other thing is, some of you are like leaving parentheses off points. So instead of like writing -2, 0, you might just write -2, 0 without the parentheses, but we should put the parentheses when we're talking about the point, right? Now, I did give full credit. I gave full credit to people who just wrote like -2, -1, and 2 here. I gave full credit to that, all right? But to be fussy, I really should have taken some points off, because I asked you to find, well, actually, no, I can't. I can't take points off here for that, because why? What's the difference between my wording for problem 3 and my wording for problem 2? You notice what I forgot to write here? I should have said fill in the blanks below for y equals by putting the coordinate or equation as appropriate for these if I wanted to be fussy about it. See, because this is the coordinates, this is the equation, and this is the coordinates again, right? So coordinates is x and y. Do you see the difference here in wording? Like in problem 2, I said find the coordinates of the x-intercepts, the vertex and the x-intercepts, right? So when I say coordinates, that's a pair of numbers, x and y coordinates, yeah? So a Cartesian pair. 4 comma -5, 4 plus or minus √5 comma 0. You know, these are coordinates of the x-intercepts. Now, you know, as a point of order, you can get away with just referring to the x-coordinate of the feature you're talking about in many cases without confusion, right? So like, I think your answers are totally legitimate to just put -2 here, to put -1 here, and to put 2 here. That would be completely legitimate. But my point to you is, if I asked you, if I pushed you on it, you ought to be able to tell me, well, what I mean is that -2 comma 0 is on the graph. What I mean is that x equals to -1 is a vertical line that the graph does not touch, right? It's a vertical asymptote. And what I mean over here is that at 2 comma 4/3, that's where there's a hole in the graph, right? So these things we should understand. You may or may not have understood those things if you simply wrote -2, -1, and 2. And that's why on a lot of your papers I wrote x equals -1 under you just writing -1 there. I'm not saying you're wrong, I'm just saying you could, you know, be more precise about what you mean there. In fairness, my wording didn't demand that, so I didn't take points off. Enough about that. Any questions? You have questions, just jump in, okay? So number 4 is easier than you think. All right, let's walk through it. 3f of 2. That's 3 times f of 2. What is f of 2? You go over here. Here's the graph. F of 2, right there. F of 2 is equal to 2. So I have 3 times 2, which is 6. All right? That's all there is to it. Part B, fg of minus 1. This means f of minus 1 times g of minus 1. This is called the product of the function f and the function g. And so f of minus 1, if you look over here, f of minus 1 is 0. G of minus 1, if you calculate, it's 3 minus 3, which is also 0. So this actually ends up being 0 times 0. So there's lots of ways you could have seen that that was 0. Yeah? Any questions? The last one is the one which is by far the most confusing, I think, for students, which is the composite. So here we have f composed with g, which means f of g of 1, which means that we have to feed g of 1 into f. G of 1, it turns out, is also 0 because it's 3 minus 3. Because I plug the 1 in here, I get 3 times 1 squared minus 3, which is 3 minus 3. So g of 1 is actually equal to 0. So then I have f of 0. Well, what's f of 0? Well, then I have to go over to the graph. When I plug 0 in, out pops 1. So f of 0 is 1. So that's why the answer there was 1. So you're looking for 6, 0, 1. So, well, anyway, a lot of people had at least one part of that right, okay? Now, there's a few of you that I looked at the graph on number 5, and your graph was like so pretty and so nicely done that I gave 2 bonus points, because I don't always do that, but you have to understand that kind of thing happens in my grading. If I'm in a section and I'm about 15 students in, and all I have seen is garbage, just garbage. I know of no other way to say it. Well, trash, yes, rubbish, refuse, dumpster fire. You get the idea. Anyway, so like very, 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 very wrong. Like just 15 people, just nothing. Just ah. And then finally, out of the ashes, I saw this, something like this, like close to this. No color, of course, but you know, pretty much this. And I was like, oh, someone understands. I must give bonus points. So this is, you know, I can't predict when that's going to happen. It's kind of, it's just a circumstance of the grading. You know, make sure if you can turn in your solution after like a lot of other people that seem like they didn't know what they're doing, that increases the chances I'll get bonus points, something like that. But anyway, so I did give some bonus points for this if I thought your graph was especially neat and tidy. But anyway, there's a lot going on here, right? So things I'm looking for in terms of giving points. Obviously, there should be vertical asymptotes, right? -6 and 4, they should be in the right place. That's because we've got division by 0 in at those points, right? The other thing I'm looking for is a bounce at -2, right? Because we've got this x minus 2 squared up here. So I need to see a bounce at -2. And then another thing I'm looking for is a horizontal asymptote of -2. The reason for that is the degree of the numerator and the denominator is both 2. And if you look at it, the leading coefficient is -2. Of course, you could have also done long division to see that, but the horizontal asymptote is y equals -2. And then also looking for like obviously a correct sign chart. There's a fair number of people who had something that looked kind of sort of like this, but just for some reason or another ended up doing one of these deals. You know, they crossed through the x-axis like that. And obviously that's not what happened. So. But anyway, there's a lot of you, I know maybe half of the class is half right about this problem right now, okay? 40% of the class is really, really lost on this problem, right? And then the other 10% are close to correct or got bonus points, right? That's kind of the lay of the land here. But it's not too late. You can figure out how to do this before next Wednesday, right? You just have to like follow the guidelines, right? Look for your vertical asymptotes, look for your zeros. You know, I tried to make things a little bit simpler here. You notice that I intentionally did not test you on hole in the graph and this stuff at the same time to try to make it like a little bit less of a cognitive load for you on the test. That's why I separated off the hole in the graph to the other problem so that you could just focus on this issues here. So don't count yourself out on this problem. This is something everybody can do, but you got to figure out what went wrong for you, you know? But anyway. I'll shut up about that unless there are questions. No? So here, I think you guys are pretty lost. You didn't understand what you're doing, let's say. So let me try to go back through this problem again here. So I tell you, you've got this cubic polynomial. Here's the formula for it, right? I say evaluate f of 1 and f of 2. What does that mean? What do we mean when we say evaluate? Plug in the numbers, right? Plug in. So why would I say that? You know, that's a hint, basically. My hint to you is that evaluating those numbers is interesting, right? And the reason it's interesting is if you plug in 1 or if you plug in 2, you should get 0, right? Now some of you didn't get 0, and that's unfortunate. That's just, I can't fix that for you. If you didn't get 0 there, then that's arithmetic's working against you there, you know. But actually, if it, you know, technically speaking, even if you get one or the other of these as 0, that should be enough for you to crack the case here. See, because once you have one of them as 0, you know that x minus 1 is a factor, or x minus 2 is a factor, right? And at that point, you can divide out x minus 1 or x minus 2. What does that leave you with? If you take a cubic and you divide out, if you factor out a linear factor, what you're left with is linear factor times quadratic, right? And so if you had, even if you had evaluated one of these wrong, as long as you could do this step with like a linear divisor, you'd end up with a quadratic up here, and then you could still have factored the quadratic after that step. Right? Once you get a quadratic, you can factor it because you can use the quadratic formula, you can complete the square, you do what you need to do, but any quadratic we can either factor or prove it can't be factored. There is no quadratic which escapes our grasp. Right? We completely own the quadratic problem. They're like a level 2 boss to us at this point. Something like that. Level 2, sorry. I'm an idiot. But anyway, so what I did was I said, well, x minus 1 and x minus 2 is a factor. So that means the product of factors is a factor. So we multiply those. This gives me this quadratic, x squared minus 3x plus 2, and I just divide that in. And when I do that, out pops x minus 3. So apparently, f of x is x squared minus 3x plus 2 times x minus 3. But remember, undoing the multiplication, which is called factoring, right? Unmultiplying is factoring, right? X minus 1 times x minus 2 times x minus 3 is what this was. All right. So some of you have not internalized the idea that if we have a 0 for the function, right, that means there's a corresponding factor, right? And then what do you do with that information? Well, you can use long division to actually do the factoring, right? So like there's varying degrees of certainty about the truth I just told you with different students in here, and everybody needs to sort of get that in your thinking. You should have that as a game plan when you hit this problem. You should be thinking ahead of time, like, what am I going to do here? I need to figure out, is there a factor? If there is a factor, I can use long division to divide it out, right? Now some of you have been cheating on me with other math instructors and or tutors. I can tell, because I saw evidence of synthetic division here, which means you've been going outside the sacred bond of our class and finding math from other people. But I'll allow it, as long as you do it correctly. And so I don't know, there may have existed a student who did synthetic division here and got correct answer. I don't remember. I mean, it's possible. You could do 2 synthetic divisions, one for the 1, one for the 2. You could. Right? And it would get you to the same place ultimately. But it is just much easier just to multiply and do the long division. All right, I shut up. Problem 7. So, Friday before last. I think it was last Friday, wasn't it? We did complex zeros the whole day. Remember, I wrote the theorem, complex zeros theorem, and we just looked at how a complex root corresponds to a prime factor. So that's what this problem was about. If we have 1 plus 2i, we're looking at alpha equals to 1, beta equals to 2 in my alpha beta jibber jabber, remember? So that gives me x minus 1 squared plus 4 is a factor of the polynomial. And if I multiply that out, that gives me x squared minus 2x plus 5 as a factor of f of x. On the other hand, we have that 5 is a factor of f of x because f of 5 is 0. So that's just the plain old garden variety factor theorem, right? There's a few theorems I want you to understand for this test, right? Like, chief among them is the factor theorem. Close second to that is the complex zero theorem, right? Maybe after that, the long division theorem. I'm not sure that's really a theorem, but what long division means for us with factoring is important, right? But anyway, so I have these two factors, right? Which means I've got this and that. Now, how do I know that's all there is? What was I told here? I was told it was a cubic, right? What does that mean? What does it mean? Cubic means third order. The leading coefficient is on the third power of x. So if I've got a linear term and I've got a quadratic term, that's all you got room for. So if your budget is a cubic, if you've got a quadratic and a linear, then you're done. That's it. And so, but we do need to figure out what the coefficient out front here is a. Notice that f of 0 is 50, right? That was given. See it? So what is f of 0? Well, evaluate f at 0, right? We get minus 5 from the first factor, and we get 5 from the second factor. So I get a times minus 5 times 5 equals to 50. So if I divide both sides by minus 25, I get a is equal to 50 over minus 25, which is to say a is minus 2. Now, my apologies, like this is not enough white space. Like if I give this problem again on the test, I should add like another inch for you guys to work in, I think. Like this one's a little smushed. All right, sorry about that. If you ever feel smushed and you feel like you need more room, what you should do is you should leave yourself some room to write the answer. You should put an arrow on it and say on the back, and then you just turn the page over or work on the previous page of the test and write your solution over there. I always print tests single-sided so that you have room to work on the back of other pages. That's why I do that. And also to make Al Gore angry. So I don't know if anyone told him about me printing tests single-sided, but I hope someone does. So he can wallow in misery in his 20-room mansion that uses 10 times the electricity of a typical Tennessean. But anyway, sorry. I was going to say something about Captain America, but we've all forgotten. Wait a minute, no. I was thinking Captain Planet, but we've also forgotten about him. Captain America, we're still working on forgetting. What's that?
Blue guy with green hair.
The blue guy with green hair. Ooh, you're doing better than me. And there's Gaia's, there's something Gaia's in that, right?
Yeah.
Yeah. The rings?
Yeah, they have like.
Yeah. See, when I was little, the big thing was either Transformers, G.I. Joe, or well, He-Man for a time. You had your Thundercats, and then what was the other big one? Oh, Voltron. Voltron was huge. We love Voltron. The toys are so cool.
How old is Thundercats?
It is like mid '80s, but yeah, this is the Voltron we were watching. I love Voltron, and at some point my mom like watched an episode of it, and then she's like, "You're not watching that again. It's horrible." And like, I mean, she just said it was stupid. I think the more complete answer is it's full of occult nonsense. Like all of the 1980s cartoons have like witchcraft in them, like just straight up witchcraft, really, if you watch them. So yeah, we lost our Voltron watching privileges like in the middle of it. He was stuck on a planet, a magnetic planet somewhere. He couldn't get off. We don't know what happened to this day. I don't really know. I should probably rewatch it. Now the updated Voltron, they've divided all the they've divided out all the witchcraft and replaced it with like alien robot stuff. Alien space magic.
Yes.
See, I have less objections to that. But anyway, it's called sci-fi.
No, they have alien space magic. I understand the genre.
Oh, really?
It's alien space magic.
It is actually alien space magic. Huh. Okay.
I missed that.
I feel like I may have digressed slightly from the quiz. Sorry about that. So notice the reason I'm multiplying. Why am I multiplying this one out? Why didn't I multiply that one out? What's the difference? There's a big difference. Right here. Standard form. I said find the standard form. I put it in bold. See that? Standard form. That means that you have to write it as a sum of powers, right? It's annoying. Like if you see an instructor put the word standard form for your answer, you should be like, ah, jerk. Because that means you got to multiply it out. All right, so that was that. I did not put standard form here, so you did not have to multiply this one out. Some of you did, though. Are we good? So this one here, I feel like as a class, you guys are much closer to being completely right about this problem than the other ones. Like almost everybody had figured out that you need an x plus 6, an x plus 2, and an x minus 4. Almost across the board, everybody has those factors in their answer, if you put an answer here. There are people who left it blank, and I understand, you know, listen, my quiz is a week ahead of the test on purpose. I want to give you a little, like hopefully enough time that there's a chance that you can figure out what went wrong and fix it. That's why I'm doing the quiz a week ahead of the test. Now, a consequence of that is sometimes you're not quite done understanding the material yet, you know, which is why I put 10 bonus points on the quiz to try to adjust for that. That's the logic here, if you're wondering, right? I realize giving you a quiz on stuff you don't completely understand is slightly unfair, right? But what's more unfair is for me to just hit you upside the head with a test without ever having any in-class experience with the material before, right? Because doing homework in my labs and doing the problems on the page are two very different things, yeah? So I please, like, take advantage of what the quiz is for you. It is a pretest. It will help you if you let it. Anyway, so a lot of you had at least these factors, but a lot of people just like to bounce. So like I got people bouncing all three. You got like squares here and here, which is, you know, which is a cool formula and stuff, but it doesn't get you this picture over here because we're crossing at -6 and crossing at 4. And some of you even put a cube, because I think you're thinking like, well, we had that example in class where we put a cube there, right? So surely there's got to be a cube here somewhere. I haven't seen a cube anywhere else in the test. It must go here. That's not how it works. Like, you got to think about it. So least degree. So a single power will do. All right. Anyway, so once you've ironed that out, we have f of 0 is -48, which means that we need to plug in 0. We get 0 plus 6. 0 plus 2 squared is 4. 0 times -4 is -4. And so that gives you this equation. Solving for a, I get -48 over -96, which is a half. So I get 1/2 x plus 6 times x plus 2 squared times x minus 4. Some of you are not really thinking through the algebraic process of finding the a. You're just like trying to write down what a is on the basis of f of 0. I think some people have put like -48 times this. Other people are adding 48 to the end. This is much further from the truth, actually. Like, definitely you don't just add 48 over here somewhere. That does not make sense. So it has to multiply the whole thing. And then finally, here's the last one. So we have f of x is 3x to the 5th plus 11x cubed plus 2x squared minus 10. The question is, does it have a factor of x cubed plus 2? All right. So that long division theorem I was talking about, really what I'm talking about is the remainder theorem. Well, I don't know what, maybe it's the remainder theorem. The remainder theorem says that if you do long division, well, that's not it either. I'm not sure what to call it, but the bottom line is, if we divide f of x by g of x, if g of x actually was a factor of f of x, then the remainder should be 0, right? If it's non-zero remainder, that means that you didn't actually have g of x as a factor. See, so I do the long division here, right? So I start out with a 3x squared, multiply that by this, that gives me 3x to the 5th plus 2 times 3 is 6x squared. I subtract these from that, and that gives me 11x cubed. 2 minus 6 is -4. I got my -10. Then to get this 11x cubed, I add 11. 11 times x cubed is 11x cubed. 11 times 2 is 22. I subtract. I get -4x squared minus 32. I'm done here. Why am I done here? Because the degree of this remainder right here is 2. What's the degree of my divisor? It's 3, right? So once the degree of the remainder is smaller than the degree of the divisor, that means the long division is done. Because there's no way you can subtract a multiple. You can't subtract from this a multiple of that, right? That just doesn't work. To quote my community college professor, this dog does not hunt. Anyway, so non-zero remainder, that means it does not factor. All right, so I took a point off because a lot of people, because I asked you to answer the question, and a lot of you have not answered the questions. Others of you have answered the question, but your long division is far from correct. So I took off points if you didn't answer, if you had a correct long division, but you didn't actually say, you know, it doesn't have factor, I took a point off, I think. If you had the right answer, but your long division is far from correct, I took off 2 points, I think. But anyway, once you have this, we can multiply by x cubed plus 2, and that gets us to here, right? So you notice, like, if x cubed plus 2 was a factor, you should be able to write some polynomial times x cubed plus 2. But this is kind of as close as you can get to it. See? Like, this is sort of as close to factoring as you can do for this x cubed plus 2. That's another way to think about it conceptually. This is the closest we can get to factoring out x cubed plus 2 in some sense. So I don't think that's something I've told you guys before. It's just I'm just sharing that with you now. Hope you don't mind learning something in the quiz solution. So I think anybody here who, you know, made like 20 or less on the quiz, I think you can vastly improve your score on the test, right? If you look at what you got wrong, you should see that there is nothing stopping you from doing better on the next one, right? The test will be similar to this quiz, right? So if you can really understand these problems carefully, I will probably give you similar problems on the test. We'll see what happens, right? Not the same problems, but similar, right? Like I might make the first problem involve a little bit more thinking than I did this time. And if I ask the complex zero theorem question like I did, I'll give you a little bit more space to work it out, yeah. But any questions? Yeah.
Do you remember what lecture it was when you went over when there's like the same zero in the numerator and denominator in 3 different cases?
I think that was this. I think it was a Monday. It's getting nuts. What section are we in? 2, right? 3. This is starting to get very meta. All right, let's see here. I think it's this. I think it's that one. Ooh, wow, that's close up. Let's see here. Oh, shut up. Let's see here. Heard enough of you today. So I think it was this one, right? Oop. Hope they don't give me a copyright strike. I think it was this one. So the 12th. Now, anyway, I think that's pretty much it. So, what's that? Yeah, if I could. So now, someone next test review needs to ask me about when did you look at, so we can come back and watch this video, and then we'll at least have 2 layers. I have a friend. I know a friend of ours from. Well, we met him here. I used to. I'll get my voice back here eventually. She used to be my secretary when I taught Awana. I used to be the Cubbies leader or whatever for one of the Awanas around here. And she takes a picture of her daughter every year, holding a picture of the picture she took of her daughter the year before. And like they keep doing it. It's very cool.
That'd be so great.
Yeah.
Is there a top hat first?
There is no top hat because the internet's sketchy today.